At 2:35 in the morning Eastern Time on August 5th, 2026, a 45-foot chunk of a SpaceX rocket slammed into the moon at 5,400 miles per hour, 7 times the speed of sound. That's what this video is about, how a rocket stage that launched a year and a half earlier ended up on a collision course with the moon, completely by accident, and how scientists turned that accident into one of the best natural experiments they've had in years. Here's the strange part. SpaceX never aimed for this. Nobody planned it. And once it was set in motion, almost nobody, not even NASA, could stop it. So how does a piece of machinery go rogue for 19 months without anyone noticing until it's too late? And why were scientists actually excited about it hitting? By the end of this video, you'll know exactly how this played out, minute by minute, right up to the moment of impact. This story starts on January 15th, 2025. A SpaceX Falcon 9 rocket lifted off from Cape Canaveral, Florida, carrying 2 private lunar landers. The first was Firefly Aerospace's Blue Ghost. The second was Resilience, built by the Japanese company iSpace. Blue Ghost landed successfully in March 2025, a huge milestone for a private company. Resilience wasn't as lucky. It crashed just before touchdown in June. Both landers went their separate ways. But the rocket part that sent them there, the upper stage, didn't go anywhere. It just stayed, and that leftover piece of hardware is the real subject of this story. What happens to a rocket stage nobody's flying anymore? That's exactly what we need to understand next, because it explains everything that follows. Quick technical detour, because it matters for the rest of the story. A rocket launches in stages. The first stage muscles the rocket out of the atmosphere, then falls back, or with SpaceX, sometimes lands itself. The second stage, the upper stage, carries the payload the rest of the way. Normally, SpaceX deorbits its upper stages shortly after launch, steering them back to burn up safely in Earth's atmosphere. But this mission was different, getting 2 landers all the way to the moon, used up almost all the stage's remaining fuel. There was nothing left to steer it home with. So it was abandoned, left drifting at around 8,800 pounds, roughly 45 feet long, not orbiting Earth, not orbiting the moon, just caught in a slow tug of war between the two. A dead rocket, drifting with no engine, no control, no plan, for over a year. So who actually spotted where it was heading? Not NASA. Amateurs. A space tracking expert named Bill Gray runs software called Project Pluto, originally built to track asteroids and debris. Independent astronomers used publicly available tracking data to keep watch on this dead stage. And slowly, the numbers started pointing at one thing: a moon crossing high Earth orbit, drifting straight toward a collision. NASA's Center for Near-Earth Object Studies, the team that normally watches for asteroids that could threaten Earth, ran the numbers too and confirmed it. No danger to Earth whatsoever. This was a moon-only event, and a fairly predictable one. Here's the part that stings a little. SpaceX could have avoided this. A small nudge right after launch could have sent the stage into a safe solar orbit instead. That nudge never happened, and that's exactly why this crash was already written into the sky a year and a half in advance. If everyone knew this exact moment was coming, the real question becomes, what would it actually look like when it hit? This is the moment the whole video has been building to. Scientists pinned the impact window to 2:34 to 2:35 a.m. Eastern Time, 6:35 a.m. UTC, striking near the moon's Einstein crater on a part of the western limb that was catching sunlight at the time. Speed at impact, 5,400 miles per hour, 8,700 kilometers per hour, 7 times the speed of sound. When roughly 4 tons of metal hits at that velocity, the numbers get dramatic fast. Researchers estimated the crash would carve out a crater around 89 feet across, about 27 meters, several meters deep, and excavate millions of pounds of lunar soil in the process. And because the moon has no atmosphere and much weaker gravity than Earth, that excavated dust doesn't just settle nearby. Estimates suggested debris could scatter as far as 500 miles from the impact site. Could anyone actually see it happen live from Earth? Almost impossible with the naked eye. The moon sits roughly 225,000 miles away. But 2 spacecraft were already in position, watching. So who exactly was watching, and how close did they actually get? NASA's Lunar Reconnaissance Orbiter was tasked with capturing before and after images of the impact site, passing over roughly a week before and a week after. Even more dramatic, South Korea's Danuri orbiter was scheduled to pass within just a mile or 2 of the rocket stage, only minutes before impact. An almost impossibly close encounter, purely by orbital coincidence. Together, these 2 spacecraft will eventually hand scientists a before and after record, crater size, debris spread, all of it. But don't expect instant results. Processing and releasing that imagery is expected to take 1 to 2 weeks. So if this was basically guaranteed to happen, why did scientists treat it like a gift instead of a nuisance? Reason 1, this is rare. Humans have intentionally sent hardware to the moon many times. An unintentional collision like this has happened only once before in history. Reason 2, it's a natural experiment. Because scientists knew the exact time, place, and speed in advance, they could prepare instruments ahead of time and capture real before and after data. That's valuable for understanding how the lunar surface reacts to high-speed impacts, how far dust travels, how deep craters form, which matters directly for NASA's Artemis program and any future permanent lunar base. Reason 3, it's a warning. As more countries and companies send missions to the moon, junk is starting to pile up there too, the same way it already has around Earth. This crash raises an uncomfortable question. Should companies be required to safely dispose of upper stages after every lunar mission, the way SpaceX could have done here? If nothing changes, the same orbital traffic jam we've built around Earth could start repeating itself around the moon. So what did the people who study this stuff for a living actually make of it? Researchers who track near-Earth objects called the accuracy of this prediction an achievement in itself, pinning down the exact moment and location of a small, distant, uncontrolled object's impact isn't trivial. A scientist from Los Alamos National Laboratory, who led the observational study on this event, pointed out that with no atmosphere and low gravity, lunar dust spreads dramatically farther than it ever could on Earth. NASA reiterated there was zero risk to Earth and framed the whole event as a rare, low-cost opportunity, free training data for tracking similar objects in the future. Which brings us back to where we started. What does one dead rocket stage actually teach us? So that's the full story, a discarded piece of rocket, launched in January 2025, drifted for 19 months, and slammed into the moon on August 5th, 2026, near the Einstein crater. SpaceX never planned it. It wasn't a disaster. It turned into one of the more useful accidents in recent spaceflight. 3 takeaways. 1, nothing in space drifts forever. Everything eventually meets something. 2, our tracking technology is now precise enough to predict the path of a dead object like this, months in advance, down to the minute. 3, as we send more hardware toward the moon, our responsibility for cleaning up after ourselves needs to grow just as fast. If you found this useful, hit like, subscribe, and let me know in the comments. Should there be stricter international rules for disposing of rocket stages? See you in the next one.